We print documents and photos from our computers daily. Most of us in the developed world effectively run a home printing press and a home photographic lab, courtesy of this technology. Suppose you could plug a 3D printer into your computer. This 3D printer makes solid, strong plastic goods from designs that you've created yourself or that you have downloaded from the web. You could make lots of useful stuff that, at the moment, you have to buy. In effect, you would be running your own factory alongside your printing press and your photographic lab. There's nothing new about 3D printers. They have been around for almost 30 years, but all the commercial ones are very expensive. They typically cost about €20,000. This is the werkt 3D printer working. You can make it yourself, and doing that will only cost you around €500. What's more, following the principles of the free software movement, the designs for the werkt machine are being distributed to everyone free under the GNU General Public License. And here is the really clever bit. Those designs include all the plastic parts for the werkt machine itself. So, if you have a werkt machine, you can print a new one for a friend. Werkt was thought up by Adrian Boyer at Bath University.
I started the werkt printer by a biomimetic analogy. That is to say, an analogy taking an idea in nature and putting it into engineering. The object in nature that I copied was the phenomenon of symbiosis. In particular, if we look at the symbiosis between the insects and the plants, which has been running for 130 million years since the late Jurassic, that is an incredibly successful and stable symbiosis. And we all know how it works. The plants need to pollinate each other, but they can't move, so they make nectar as well as pollen. The insects visit the plant to obtain the nectar, and in doing so transfer the pollen to the other plant. The insects get a meal, the plants get to reproduce, everybody's happy, both species benefit from the relationship. The werkt printer is intended to be exactly the same, with people taking the role of insects and the printer taking the role of the flowers, because the werkt printer doesn't just copy itself, it also makes useful goods. And those goods are the equivalent of the nectar, and that nectar, those goods, rewards the people who assemble the machine, because those people are helping the machine to reproduce in just the same way that the insects help the flowers to reproduce. The werkt printer works by melting plastic and then building it up into three-dimensional objects which solidify when they cool. It starts with a filament of plastic about 3 millimeters in diameter, rather like a piece of wire. And that filament is fed into a melting head in the machine and then extruded out of a very fine hole. The machine then scribbles with that molten plastic onto a flat plate to make a layer of the object that's to be built. The plate then drops down by a small fraction of a millimeter, and the next layer is scribbled on top of that, and so on until the whole component has been built in 3 dimensions.
Vic Oliver from New Zealand is another member of the team.
I just love the ability to design something, have it made right there on my desktop, and then realise I've done it wrong, correct it, leave the thing printing, come back in the morning and there it is, perfect and glorious.
There are 16 people in the core werkt team from all over the world, and many others who help informally. The writing of the software and the documentation is done by this collective, as is the design of the electronics and mechanics. All the software, documentation and designs are published and shared on the web using wikis, blogs and SourceForge. Ed Sells is one of the principal people involved in the mechanical design of werkt.
One of the key challenges to designing the printer is to design it in such a way that it can make its own parts. For the first version, if we do a simple part count analysis on the design, we find that it can make about 50% of its own parts. As we develop the second version, which is what we're currently working on, we hope to improve this ratio to bring the number of parts that it can make for itself up. We hope to do this by developing new deposition heads so that we can print in new materials and increase the functionality of the printer.
In May 2008, werkt achieved replication for the first time. This parent machine made a complete set of parts that were then used to build this child machine. The child machine was immediately put to work making grandchild parts. The team are now working on version 2 of the werkt machine. Version 2 will, of course, be printed by version 1, as well as being able to print itself. Version 2 will allow a wider range of materials to be printed, including electrical conductors, so that the machine can make its own circuit boards and other electrical products.
If RepRap's successful, a number of changes may well happen in society. The principal one of them will be that we have the distribution of the manufacture of goods. At the moment, economies of scale mean that it's sensible for goods to be manufactured in factories and then to be shipped to individual people who wish to have those goods using a complicated transport system. If RepRap takes off and increases its abilities by evolution to manufacture more and more products, then people having these machines in their homes will mean there will no longer be a need, or no longer be such a big need, for factories to make the goods that they want. When they want something, it'll simply be a question of downloading it from the web in the way that they currently do with music or a film or anything else, and that downloaded file would then allow them to manufacture whatever object it was that they wanted in their own home. No transport involved, except for the raw materials, which have to be transported anyway, of course. And thus we have short-circuited a large part of the conventional supply chain for material goods to individuals.
Then you can make one for your friend, and then there are 2 RepRaps, and then you can both make more RepRaps for more people, so it goes exponentially. There are 4, 8, 16, 32, and before you know it, everybody in the world's got, who wants one's got a RepRap, and nobody can hold the monopoly, so it keeps the cost down.
Chris DeBona, open source programs manager at Google, said, "Think of RepRap as a China on your desktop." And Sir James Dyson, inventor of the Cyclone bagless vacuum cleaner, said about RepRap, "Advanced fabrication technology that can copy itself is a truly remarkable concept with far-reaching implications." The objective of the RepRap project is to give away the designs for a machine that anyone can use to make many of the goods that we all currently have to buy. And anyone can also use their RepRap machine to make more RepRap machines for other people. The project aims to put a factory in every home, a factory that can make more factories.